Welcome to this edition of Mr. Wood's Awesome Math Class, and welcome Bloomfield students. Today, we're going to be looking at discontinuities and domains. When there are holes, when there's vertical asymptotes, how do we find the domain, and how do we actually calculate what those vertical asymptotes are? All right, so there's a couple of different types of discontinuities. We talked about there's one called holes. So holes are things that look like this, that you have a function and then all of a sudden there's some kind of piece. So like that right there would be considered a hole. So you have a function or some kind of graph and then there's one little small piece that it can't be. This is like a jump, so it would go from here to here, so that wouldn't be necessarily a discontinuity. We have a vertical asymptote. All right, and so there's also none, or these can be continuous. So that would just mean any kind of graph. So if I didn't have a vertical asymptote, it could be any kind of graph that would be continuous, some kind of line that would continue across all domain or all real values. So those would be the ones that would be continuous. So this refers to all possible x values of any given function. So we either have vertical asymptotes, holes, or none when it refers to domain and the any issues with domain. All right, in this one, I already kind of alluded to some vertical asymptotes when we were talking about what's the excluded values, right? Excluded values that we were doing yesterday or doing the other day. Excluded values. Anything, so we know it can't be a zero in the denominator. So same way as for vertical asymptote. So all I do for this first one, in order to find it and then classify it, so if I have x minus 5 over the x plus 1, all I care about is when is that equal to 0? Well, we know x plus 1, when you set that equal to 0, x can't be at negative 1. So at negative 1, we get a vertical asymptote. So that would give me my vertical asymptote. Okay, and here, once again, all I care about is the denominator. So if I say x plus 3, and on the top I had x plus 3, well, we know those divide out. But this was still a denominator. It said x can't equal negative 3, right? But this would create, because it actually divides out, we get a hole. So holes occur when something is divided out of your original equation. But then what happens to this other piece? If I have the square root of x minus 2 and we set that equal to 0, well, when is x not valid here? Well, if I square both sides here, right, I get x minus 2 equals 0. So here x can't equal 2. And so my vertical asymptote would occur at x equals 2. So that can't occur either. So I would have in this problem for number 2, we would have a hole at negative 3 and a vertical asymptote at x equals 2. All right. For problem 3 here, well, I don't care about what happens in the numerator. I only care about the denominator. Well, we know 4 can never equal 0, so that doesn't do anything. So number 3 would just be continuous, or this would be none. Vertical asymptotes, we know, are non-removable. Holes are removable. Vertical asymptote, not removable. So that's when it says find and classify. So this vertical asymptote here at negative 1 would be non-removable discontinuity. All right, so here for number 4, we actually need to factor this out first. So I have x plus 1 in the top. Well, when I factor this out, I have an x, and that's going to leave me x squared plus 5x plus 6. And when I factor that more, so when I factor that out in the bottom, I'm going to get x plus 2 and x plus 3. Okay? So once again, all I care about is what happens to the denominator. So here, well, x can't be 0. So at x equals 0, we have a vertical asymptote. At x equals negative 2, we have a vertical asymptote. And also at x equals negative 3, we have a vertical asymptote. So that would give me a couple of different pieces there. Nothing divides out. All right, what about on this one on 5? Well, we have so this is 5. 2x plus 1. And then if I factor that out, what am I going to get? Let's see. So I got 2x and x. Factors of 7 would be 7 and 1. So in order to get the negative 13, this would have to be negative and positive. So what do I got? I got 2x plus 1 divided by 2x plus 1 and x minus 7. So these will divide out, right? So if I set 2x plus 1 equal to 0, that would tell me x equals negative 1/2, and that would be a whole because it actually divides out. Here, if I set x minus 7 equals 0, I get x equals 7. At x equals 7 would be a vertical asymptote. So those would be our pieces. There are discontinuities for 4 and 5. For 6, there is no x in the denominator. Nothing in the denominator, so this would be continuous, or there would be none. There'd be no discontinuities for that one.